All right, guys, we'll take a look at 9.1. So a point estimate is the value of a statistic that estimates the value of a parameter. We're going to find some confidence intervals for population proportion. So to do that, we're going to go to Stat, down to Proportion Stats, one sample with summary. And we're going to enter X by N and then click confidence interval. So we've got 405 have donated blood in the past 2 years out of 2289. So 405, 2289, and we want a 90% confidence interval. So 405, 2289, we want a 90% confidence interval. So here is our sample proportion. That's going to be p hat, and then the lower and upper limits here will be your confidence interval. So point estimate here, part A to 3 decimals is 177. And then the way we interpret a confidence interval is we always say we are 90% confident, not chance. So we are 90% confident the proportion of adults in a country who've donated blood is between here and here, going to 3 decimal places. Is 164 and 19. And we are 90% confident. And then we'll repeat. So here we want to get a point estimate for those who believe televisions are a luxury. So out of the 1,028, 536 indicated luxury. 1,028, luxury 536. So we can do 1,028 minus the 536. And that gives me those who think televisions are a necessity, 492. So we're going to do luxury 536. Sample size 1,028. And we want a 95% confidence interval. So our point estimate to 3 decimal places is 521. And then lower limit is 491. And upper limit is 552. So again, we're always going to choose confident and then 95. Lower limit 491. Upper limit 552. All right, so now this interval here is the most likely percentage of Americans who believe televisions are a luxury item. So is it possible that more than 60% believe televisions are a luxury? Well, it is possible, but not likely, because the most likely values are between here and here. So it is possible, but not likely, because the 95% confidence interval does not contain 0.6, which is here. All right, now we're going to do 95% confidence interval for those who believe televisions are a necessity. So we just go back over here, and change the number who say luxury to necessity, which is 492. And then we want 95% confidence interval. So we get 448 and 509. 8 and 509. Okay. So here we've got 1,500 adult citizens, found 21%, dreaded Valentine's Day, margin of error of 2.1%. So this is just interpretation. So we're just going to take 21% and minus 2.1, and that puts me 18.9. So here's 18.9. So this is the one we want, 90% confidence at the proportion of adult citizens that dreaded Valentine's Day is between 18.9 and 23.1. So if you take 21 and add 2.1, then you get 0.231. So this is just interpretation only. All right, so now we've got study examine the interactions in a children's museum. So researchers found 184 meaningful interactions, 88 which were led by children, 96 led by adult. So give the point estimate for those interactions led by children, and then compute confidence intervals. So led by children were 88, so that's going to be X, and 184 is sample size. So 184 and 88. '88, 184, confidence interval, and we went 99 this time. So point estimate to 3 decimals is 478. And then 3 decimals is 383 and 573. And then interpret. So again, one can be 99% confident the interval contains, and you always want to select the true proportion because that's what we're estimating with this confidence interval. All right, now again, this is the most likely interval here that contains the true proportion. So is it possible, or suppose an educator claims the true proportion of all meaningful interactions in a children's museum that are led by children is 35%? Well, again, it is possible, but not likely. The most likely numbers are between 38% and 57%. So the claim is probably not valid because 35% is below the lower limit of the confidence interval. %, of people say coffee shops are overpriced, so the population would be the actual adults and their opinions of coffee shops. The sample is the 100 adults that were surveyed. The parameter of interest is always P, the population proportion. And now we want 90% confidence interval. To do this, you've got to get X. So you take the percentage, 48 times 100, which gives you 48. And N, my sample size is 100. So we'll go over here and do 48 and 100. And we want 90% confidence interval. Change that to 90. And we get 398 and 562. Two decimal places be 99 and 56. Interpretation. We are 90% confident the population is described by the interval for the parameter of interest. Let's see what this one says. 90% confident that the parameter of interest lies in the confidence interval. So that's the one we want to choose. All right, so this time we've got marine scientists categorized signature whistles of bottlenose dolphins by ABC. One study, sample of 185 whistles emitted from bottlenose dolphins in captivity. 95 were categorized as type A. So compute the proportion of those 185, the true proportion, who were categorized by type A. So 95 and 185. 95, 185, and we want 95% confidence. So we get 441 and 586. Now interpretation, 95% confident, the true proportion that our type A is not is not, but is within the interval found in the previous step. Okay, let's see here. Oh, rounding up here. So nearest hundredth will be 2 decimal places, so we don't need to go to the full 3 here. So let's just take off this 1, and then we'll make that a 9. Okay, so be careful on the rounding. Another confidence interval here, this time dealing with how students are involving emojis in their academic writing. So a survey of 700 teenagers were selected. 460 say that they have used at least one of these emojis in their school writing. So create a 90% confidence interval. So 460 by 700. $460 by 700, and we want 90%. 3 decimal places this time, 628 and 86. Excuse me, jot this down here. 628 and 687. 628, 687. And now we're looking for one can be 90% confident. The interval contains the true proportion of all teenagers who have used at least one informal element in school writing assignments. So that's what we want. Interval contains the population proportion, not the sample. All right, so now we're going to do sample size. And to do that, we're going to go proportion stat, one sample, and width sample size. And we're going to need a few things. We're going to need confidence interval, 95. We're going to need the margin of error, which is 0.03. And there's 2 cases. There's no preliminary estimate and then a prior estimate. So I'll show you how to do both. First is no prior estimate. So let's pull StatCrunch up. Stat, proportion stat, one sample, and you're going to go to width / sample size. All right, and you're just going to enter the confidence level, which in this case is 95. The target proportion, if there's no prior estimate, then you just leave that the same. And then over here, you're going to double your margin of error. So the margin of error is 3%, and we're just going to go to 6%. So you always double it, and then your sample size is going to be here. 1,068. So 1,068. And then when you do have a prior estimate, all you do is put your prior estimate here. So the prior estimate was 18%. So we're going to do 18%, and we're going to get 631. So again, confidence interval, sample size question here. 95% uses a prior estimate of 36%. Margin of error this time is 4%. We'll double that to 8%. And 554, sample size. And now does not use a prior estimate. So we'll make sure you double your, again, and then just go back to a half. So we get 601 this time. All right, last question, sample size again. This time we've got 94% confident, margin of error 2% will double, and then prior estimate of 52. Prior estimate of 52, 95, 2%. Yep, we'll double, 94% confident. And then we'll double that to 4%. And then 52 gives you 2208. And then a prior estimate, the first part has a prior estimate of 52%. Let's go back and make sure that, yeah, I did that. Okay. All right, and then the next part, new percentage with 94% confident and does not use a prior estimate. So we're going to do half and go back to 4% and keep it at 94% confident, and we get 2211. Okay, so I'll see you on the next video.